And welcome everyone. Thank you for joining today. As Grace said, we're going to be talking about domain-specific large vision models today. And we have myself and David here, as Grace mentioned. So just some quick introductions. My name is Quinn Killough. I'm a computer vision specialist with Landing AI, focusing on the go-to-market side. And my background is in manufacturing. I've spent my most career in manufacturing plants, but the last half of my career has really been focused on computer vision and machine vision for automation of various tasks. Been with Landing for 4 years now and have seen our company come quite a ways, and we're excited today to talk to you about this new domain of domain-specific large vision models. We also have David Park here. I'll let David introduce himself as well.
Sure, thanks, Quinn. Hello, everyone. My name is David Park. I head up our solution engineering team here at Landing. Prior to joining, I worked as a data scientist for about a decade in various industry like financial services, manufacturing, insurance, and other verticals as well. Very excited to be here and looking forward to the session.
Awesome. Thanks, David. So yeah, we'll kind of be tag teaming this presentation. I'll hand over the slides to him at some point. But before we jump into it, I wanted to cover the agenda. So what we'll be going through in the presentation. First of all, I want to start at a high level on kind of some of the macro trends that we are seeing, both in the growth of data and AI innovation. We'll back up a little bit and explain who we are as a company, Landing AI, and what our flagship product is, which is Landing Lens, and how that relates to this topic. We'll talk a little bit about the challenges that we see in the computer vision space, more specifically the challenges that we see these domain-specific large vision models helping with. And just a side note, the domain-specific large vision models is a bit of a mouthful, so I might start saying DSLVMs as we start to go through this presentation. We'll talk about these LVMs and their benefits, like what they are, how they're made, et cetera. Go through some examples of use cases where we benefit from these large vision models, and then talk a little bit about where we see this going in the future, as well as a demo of a particular tool that we're excited to apply this technology to. And then, of course, we'll have questions and answers as we mentioned at the end. So please feel free to submit your questions as we're going through this. We're really happy to take them at the end of this meeting. All right. So like I said, wanted to talk about kind of the macro trends at the start here. So I don't think it's any surprise to folks that the amount of data that's being collected worldwide is growing exponentially. But one piece that might be interesting to you is that the kind of composition of that data, a large amount of it is actually unstructured data, i.e. images and videos. So there's a huge amount of data out there, but one of the challenges that we'll talk to in a future slide here is there's not a whole lot being done with a lot of this data. There's a lot of data just sitting around, and it's not really being used to empower people with computer vision use cases. So we'll talk a little bit about how we can change that. I think it's also helpful to talk about kind of the path of AI advancements over the last several years. So I think this graphic, there's a lot on this slide, but I can kind of walk through it. But the line on the left is really talking about the advancement of text-based or language models. And you can see back in 2017, when transformers were first kind of introduced, it kind of kicked off this wave of innovation, various technologies being released and increasing exponentially into recent years. And I think we're all inundated with news on these latest technologies like the ChatGPTs of the world and Bard and so on, right? So it's been a really exciting journey to see all of that happening on the language side. But what we think is really interesting is a similar trend happening on the vision side. So the vision transformer was introduced in 2020, and we saw, again, a similar kind of trend here where various innovations and technologies were released in subsequent years, right? So everything from Clip to Dino to SAMs from Meta, and we have a few of our own innovations in here, like visual prompting, which we'll talk about a little bit later in this presentation. And the topic of this presentation, domain-specific large vision models. I think the key takeaway here is that we're still on the uptrend here, right? And we think there's a lot of innovations to come in the near future. So we're really excited about the space, and we think it's a great time to start talking about it and start seeing how we can use these large vision models to benefit us, right? So now let me back up a little bit and talk a little bit about who Landing is as a company. So we were founded back in 2017 by Dr. Andrew Ng. Our goal was to enable our customers to achieve value from computer vision applications. And today we offer these domain-specific large vision models. We also offer this platform that's called Landing Lens. And Landing Lens is an end-to-end platform that allows developers to come in and build, deploy, and maintain computer vision applications. And that's really where we got our start in the computer vision space, was with this Landing Lens platform. And we've applied it across a large number of industries. You can see on the slide here. So everything from semiconductor to aerial and satellite imagery to medical imaging. We've seen a huge variety of use cases, and we've seen the technology apply effectively. And we're also excited to see how the domain-specific large vision models are starting to help these industries as well. I think it's going to be helpful to explain a little bit about what Landing Lens is, because this is really what kind of put us in the space in the beginning. So Landing Lens is, like I said, it's a developer's tool. The whole goal is to enable people who are not necessarily machine learning experts to come in and kind of act like a machine learning expert and build effective AI solutions for vision tasks. And the tool is broken out into three major buckets. It is a seamless workflow end to end, but it kind of broken out into three major steps: data management, model training, and deployment. So we have tools to allow the users to manage their data sets, label data, and manage their projects, et cetera. Once we have labeled data sets, we have a quick and easy way to take those data sets, train models, and not just train them, but also evaluate them to make sure that they're getting the performance metrics that we're looking for. And then the last and key piece is deployment management. So being able to take these models that were trained and have a nice way to actually deploy them into real life scenarios. So it's really important to have flexible ways to do that. So we have mechanisms to deploy to the cloud, to edge devices, to Docker-based deployments. And it doesn't just end there either. We have ways to integrate those deployments back into our development environment. So for example, we can take production images and use them to continuously retrain our models and monitor and maintain our solutions. So it's really this end-to-end platform. I think it's also important to talk about some of the challenges that we still see in the computer vision space. In general, unutilized data is a big one. So that comes back to the first slide that I showed. There's this huge growth in data. We've seen a lot of our users, they started data collection initiatives many years ago where they're storing many terabytes of data, and a lot of it's going unutilized, and it's hard to process that amount of data. And we really feel that LVMs are going to play a big role in kind of unlocking the potential of the data that these customers have stored. We're also seeing challenges around inconsistent performance and time-consuming development, right? So getting the performance metrics that we're looking for in these computer vision models and the time it takes to get to those performance metrics can be lengthy without the right tools in place, right? And if the development time is long, then these projects don't get prioritized or they can fall off. Another thing that we see often is projects, especially when not having a tool like Landing Lens or LVMs, is projects kind of getting stuck in this POC stage, right? So they just, maybe they are building a model in a lab environment, but it never actually gets deployed to production. And that can come down to not having a nice seamless platform to do so. But it can also come down to inconsistent performance or not getting to those performance metrics that we're looking for, right? And we'll circle back to how these get addressed with the LVMs in a few slides here. Now, I did want to talk about some of the applications as well. I think it's helpful to understand kind of the breadth of applications that a computer vision can be used for. It is pretty wide. So we see a lot of things in the defect detection space, but there's tons of other applications as well, like just general image classification, scene analysis, assembly verification, object or part location within a scene, detecting anomalies within scenes as well. So there's a pretty wide range of applications that can be tackled with computer vision. So we're really excited to see how LVMs apply to these as well in the future. Now, let's talk about what we mean by a domain-specific large vision model. So the domain-specific large vision model is really a foundation model that is trained on your own proprietary data. And the LVM serves as this kind of foundation to then train and build your downstream applications with basically starting with something that understands space that you're working in. And because this foundation model understands your domain, the space that you're working in, we can therefore get better performance out of these models in less time, which are two huge benefits, right? And I think it's also important to talk about the kind of differentiators from a large vision model and a large language model, because we hear a lot about large language models today. And one thing that's nice about them is language is pretty consistent regardless of the industry you're in. There might be some key terms that are a little bit different, but these large language models can be pretty broadly applied within industry. But when you start talking about the image space, and you're looking at generic models trained on images scrubbed from the internet, it doesn't quite work the same way, because a lot of times the use cases that people are trying to tackle are very niche use cases or proprietary data. They're images and domains that would not be included in this mass data set scrubbed from the internet. So a general purpose large vision model that's trained on internet images would likely struggle on a very specific domain like aerial imagery or pathology, for example. So that's where we really see this domain-specific concept coming in. We build these foundation models on the domain's images themselves, so it understands that domain and can perform well in that domain. So this comes back to kind of translating those challenges to now the benefits of these large vision models. So because we have a large vision model, we can now understand these really big data sets. We can get insights into these collected data sets, even when they're unlabeled. So I think this is a key piece of the development process for a large vision model that people need to understand. You don't need a big amount of data that is really well labeled. You can actually do this in an unsupervised manner to train the large vision model in the first place. And that large vision model will then allow you to get insights on this unlabeled data set, right? So it allows customers to get started quickly especially because oftentimes the longest part of these projects is the data preparation and labeling process, right? Higher accuracy. So with a large vision model, because it understands the space better, if you were to give the same data set to an out-of-the-box model and a large vision model, you would get a higher performance out of that large vision model because it inherently understands the space. And then on the kind of flip side of that coin, speed to production. If you were to set your performance metrics at a certain benchmark, let's say you're looking for 90% performance on one of your computer vision models, with a large vision model, you could actually get away with training with less data. And we'll talk a little bit about how much less data in an upcoming slides here. But this is a really key piece. Like I mentioned, the data preparation part of these computer vision projects ends up being the vast majority of the time that's spent on them. So if we can reduce the amount of data that's required to go into these models and train these downstream applications, we can save a whole lot of time and a whole lot of money, right? And then, of course, seamless integration. This is a really important piece of this. So I talked about what Landing Lens is. With these LVMs, they're able to actually plug into this existing workflow, this UI-based workflow that now allows, again, these non-machine learning experts to come in and build applications and get even more out of Landing Lens than they do today. Landing Lens today is currently very easy to use. It gets very good performance. But with an LVM, you can boost that performance even further. And I think it's also important to point out, one of the questions we get a lot about this space is, well, if it's a large vision model, it's going to be really heavy, it's going to be really slow, it's going to be hard to deploy and get fast predictions like we need. That's actually not true. When we integrate these LVMs into this workflow, the artifact that gets produced at the end, the trained model, the deployable artifact, is actually fairly lightweight. and can be deployed on lightweight edge devices and run just as fast as the models that we train in Landing Lens today without the LVM integrated. So that's a huge benefit here. So with that context set, I'm going to pass the mic over to David, who will start talking about some of the applications. David, are you ready to share? I can turn over the screen to you.
Yeah, sounds great.
All right.
Thank you, Quinn. So let's double click into some of the previous slides that Quinn just shared and explore what this means from a technical standpoint. So here's his pathology example where we've seen very positive results from a domain-specific LVM. You can see the original image on the far left. But if we were to compare the heat maps visualized from the attention layer of these LVMs, you can see that the DS LVM is doing a much better job of learning from meaningful features from the original image. We've also seen that this also correlates to the results that we're seeing from the downstream tasks. So as Quinn mentioned, if we were to integrate this into the overall workflow where you're fine-tuning the LVM using Landing Lens, you're getting a very high performance. And again, comparing this to the generic LVM, which is in the middle, you can see that the model is not doing a really good job of detecting boundaries and different feature maps, and it's generally very noisy and somewhat confusing to understand. And if we dive a bit deeper, you can see that the generic LVM, again, doesn't do a really good job of differentiating different features, and the heat maps look quite diffuse, which indicates that the model is not able to hone in on different aspects of the image, whereas Landing AI's domain-specific LVM is doing a much better job of detecting and learning from these critical features. Here's another example from the semiconductor space. This is an LVM that we work with one of our strategic customers. And the primary use case being detecting defects on wafers. Again, on the original image that you can see on the left, you can see a black spot, which represents a defect. And as you can see on the heat map of the LVM, generic LVM, it cannot easily distinguish the defect from the overall wafer, whereas the domain-specific LVM does a really great job of highlighting and differentiating that defect. Again, if we were to dive a little bit deeper into this use case, you can see a similar pattern that of the pathology example. A domain-specific LVM is doing a much better job of differentiating those critical features of the entire wafer itself, as well as the defect. So what does that mean from in terms of the overall model performance? This means that you can achieve better performance with much lower effort, as Quinn highlighted in one of the previous slides. And as you can see on the error rate on the left side, where we're comparing the generic LVM or a generic LVM to one of our domain-specific LVMs, the error rate decreases with more data for both models, but for DSLVM, based on our experience, has between 36 to 52% lower error rate. And also you can achieve the same level of performance with 70 to 90% less labeled data, which is a huge gain for many of our data science teams. And this means that this leads to scalability from business perspective, and of course, generating millions in savings and value for our customers. So if we're to look at this from application standpoint, instead of scaling use cases in a specific domain linearly, as you see on the left side, this means that you're essentially starting from scratch for each use case, which can take anywhere from 2 to 6 months, depending on kind of the maturity of your data science practice. And you're going to notice that there's no knowledge transfer between projects. So you're using a lot of valuable information as you tackle these use cases in that particular domain. With DSLVMs, our customers can scale their use cases exponentially. So using the LVM as the foundation model with just a with just a little bit of fine tuning using Landing Lens, our customers can put models into production in just days or weeks instead of months for all the downstream tasks within that domain. Again, last but not least, our customers can integrate LVMs or domain-specific LVMs into our existing tech stack for a fully integrated end-to-end computer vision solution. So using a DSLVM as the starting point, our customers can upload some data, label them, and then train a model for a specific downstream task for fine-tuning and deploy them using one of our many deployment options, either through cloud, edge, using our edge computing software called Landing Edge, or Docker, which can be orchestrated using a tool like Kubernetes. So you have full control over the deployment options. And our platforms are, intuitive and very easy to use. So this enables better collaboration between your data science team and business units, which will lead to, of course, more productivity. And the flexible deployment options that we highlight in this slide means that the models can seamlessly integrate into your existing environments and any ML existing pipelines. Plus, you get the benefits of our MLOps capabilities to ensure good performance over time and continuous active learning. And one of the main key benefits of domain-specific LVMs integrating into our existing platforms is that visual prompting, which is a prompt-based model training technique invented by Landing, will be even more powerful. This allows our users to teach an AI system through visual prompts. So selecting a few sample pixels to quickly identify patterns within your image. And with just those few sample pixels per class, you can train a highly performative segmentation model. And if I can tie this back to the heat map from the attention layer, again, we're learning from those critical features more effectively, enabling you to train a highly performative model with just one or few images for a specific downstream task. Okay. To help contextualize what visual prompting is, I'll do a quick demo of visual prompting for context. So again, this is our cloud-based platform called Landing Lens. I've already uploaded some images of petri dishes with cell colonies. And again, visual prompting is a prompt-based model training technique. So if I were to dynamically create a cell class, again, just prompting a few sample pixels there. And then for the sake of the demo, I'll just call everything else background. So I've essentially dynamically created two different classes and prompted a model to say, hey, these are cell colonies, or these are what cell colonies look like, and these are what the background looks like. And with those few sample pixels, I can train a segmentation model that can generalize on future images. So if we were to compare to, let's say Sam is highlighted on the data growth and AI innovation slide, we're not just running a segmentation model on a single image, we're training a model that can generalize on future images as well. So if you look through the rest of the images, 3 unlabeled images, we've also ran inferences based on the model that we train with just those couple prompts the couple prompts on the single image that we labeled. And again, this model can be deployed in many different ways. So if you have specific deployment requirements, we can accommodate any of the environments that you have today. That is it in terms of the demo. So hopefully that gave you some idea about kind of the possibilities of domain-specific LVMs coupled with visual prompting. And as we look into the future of LVMs, I think Paul asked this question, what does LXM mean? You're exactly right. It's multimodal approach, But before we get to that, we see many benefits and applications of LVMs. Again, starting with better integration with Lending Lens and Lending Edge. This will allow our customers to tackle all downstream tasks within these domains much, much faster with a higher level of accuracy. And we'll also work with our customers on training and retraining their own LVMs as we grow and continue to innovate in this space. Second, our customers will benefit from data enrichment, so extracting metadata, understanding gaps within your data sets. We have prospects and customers coming to us saying, hey, we have millions of saved images, and I want to extract text data or metadata so I can incorporate that into, let's say, a home estimation model or other type of structured models that they have in place today. So enriching that data to build a more accurate model for some of the key business drivers for their vertical. Again, hopefully we've highlighted this, but this will lead to our customers having, again, better comprehension of not only their data, but also the domain as a whole. And additionally, we believe that this will help unlock multimodal applications like image search and image generation, specifically in synthetic data for manufacturing. So if you're introducing a new product or opening up a new production line and you want to be able to detect defects out of the gate, LVM could be a huge asset for those type of applications. And last but not least, we at Landing AI believe that the potential of domain-specific LVMs is endless. And of course, we would love to hear from you and our customers. So with that said, I will hand it back to you, Quinn, for how they can get started.
Yeah, and just I guess staying on this slide for a second, I think the much more exclamation point bullet is actually important. As you saw on that second slide that we showed, we do think that we're still fairly early in the large vision model journey in the AI space in general. So we're projecting some things here that are more closer term, but we think there's a lot more to come, and we're excited about those future advancements. And a lot of those ideas are actually brought by folks like yourself that are thinking about these in the terms of real life applications. So we're excited to hear your feedback. But yeah, David, maybe we can go to the next slide here. Just to summarize, I think we did a good job of summarizing already, but again, these are really foundation models that are trained on your own proprietary data. The key benefit is that it's going to allow you to rapidly develop your downstream vision tasks and get higher accuracy out of them. And with Landing Lens, you're able to kind of democratize this development process because we have a standard platform that's accessible to the public. And of course, if you're looking to start your LVM journey, we'll have some contact information on the next slide here, and we can get started as soon as you'd like. Maybe we can hop to the next slide here. All right, great. So at this point, I think we can turn it over for Q&A. I think we saw a few popping up as we were going through the presentation. Grace, were you planning on?
Yep, sounds good. Yeah, thank you, Quinn and David. Now let's take some time to address questions. If you haven't already, please use the Q&A section on Zoom to ask questions, and we will address them as time permits. We have already great question comes in. So let's see. The first one is, how much data should we be saving for retraining or improvement of a model in terms of time, considering that some highly regulated industry require record retention and validation evidence documented?
Quinn, maybe you can answer from the validation standpoint, but I'll try to answer it from technical standpoint. So I think that time is almost irrelevant in that I think it really depends on how much data drift and how much data drift that you see over time. So going back to kind of the manufacturing example, let's say you have a new defect that gets introduced to your manufacturing process. That information is a lot more valuable than, I guess, the duration if you're getting consistently same defects or same okay images over time. And I think from record retention, of course, having more data is important. But again, I think it depends on kind of the diversity of the data set, and we can help you kind of validate that over time. Quinn, do you want to answer from the validation standpoint?
Yeah. So we do work in a number of regulated industries, and I think there's actually benefit here in that in most cases, it's required that these images are saved for a long period of time, whereas these other unregulated images might discard their kind of production inspections after a short period of time. A lot of times we're seeing up to 6 years, I believe, that these images and inspections need to be saved, and therefore you have a nice repository to pull from to actually feed back into your models, right? I think a key piece of that is which data do you pull back into your models, right? If you're running tons of, oftentimes, if we're talking about like a quality inspection, the 99.9% of those parts are going to be good images. So how do we go through and find the unique ones, the ones that are going to benefit the model the most? And actually, that's another key area where we think these LVMs could be helpful, is actually scrubbing those production data repositories for unique and helpful images that would best benefit the retraining of a model. So I think it's a good question.
Yeah, and we have a proprietary way of selecting these data sets. So on top of the LVM, will help you identify those gaps. And maybe, Quinn, it would be worth mentioning that we have a validation ready stack dedicated for highly regulated industries. So we work with life sciences, aerospace, and
So we do have a separate version of landing lens for these regulated industries because of this whole validation concept. There's a whole lot more control around not just the models that get deployed, but also the tools and workflows that are used to create those models. So if you are interested in learning more about that, feel free to reach out to us.
Sounds good. Thank you. And how many images do you need to train, and how long your training lasts?
I can try to answer that. I think our lower limit is around 100,000, but again, 100,000 diverse images. So if you're working in financial services and let's say you're looking at approving loans and looking at images of homes for potential damages, we would ideally need to see variety in different home styles, different lighting, different color, different texture, different finishes. So I think it really depends, and we can scale up to millions of images if needed, depending on the complexity. And of course, the training time will be correlated to the number of images. So I think it will be anywhere from days to potentially weeks, depending on the size of the data set that you have.
Yeah, and I think a key piece of that is the definition of what a domain is, right? So like one of our customers might have several different domains underneath them for their various different use cases. So like defining the boundaries on those domains and bucketing the data accordingly is an important part of the LVM process. And to David's point, if there's a lot of variability within a specific domain, inherently you're going to need more images and likely a larger model to actually be able to handle and generalize to the large amount of variability. Whereas if you have like a very tight domain where all of the images are very similar, you might be able to get away with fewer images for training, like 100,000 images, like David had mentioned. Yeah.
Great, thank you. Is there or will be options that don't utilize the cloud?
Maybe I can take that one. So today, Landing Lens is a cloud-based platform for the development piece, right? So, so that's the tool that we were talking about, where you're training models, deploying them. But I should clarify in that it's actually a hybrid cloud, right? We do have on-premise ways of deploying the models, the artifacts that are actually created on-premise, right? So you really only need to add images to the cloud for the training purposes. And it's a concern with a lot of folks is the kind of security of using a cloud-based platform. I would point out that we have a lot of very secure customers that are able to use the cloud-based platform because it is a highly secure environment, and we're able to prove that within InfoSec teams. But with that said, we are looking at in the future releasing I would say a containerized version of Landing Lens that's later on our roadmap. So more to come on that. For the LVMs specifically, we do have mechanisms to train these outside of the cloud. So we can get creative in how these models get trained. We've talked very much about the integration of LVMs with Landing Lens on this call. I would also point out that there are some customers who just want the LVM and maybe don't need Landing Lens, right? And we are open to those types of engagements too. And we have kind of creative ways to train those models on secure environments that don't have to be in the cloud. So I hope that answers the question.
Thank you.
I don't know, David, if you have anything to add on that.
Yeah, no, I think you answered it perfectly.
Yeah, I think the related question, following question is, as LVM is large, how do you reduce the model size for edge application?
Yeah, we apply our specific model distillation techniques to going back to Quinn's point on making the models more lightweight for high throughput inferences. For some use cases, given you have the right hardware, we can scale up to 30 to 60 inferences per second. So any high throughput use cases, we can help with those. We can accommodate those as well. Quinn, anything you want to add there?
No, only the I guess the concept at a very high level, the foundation, the large vision model isn't actually what gets deployed, right? I think that's what you have to keep in mind. It's the downstream, the model that gets built on that is actually much more lightweight that is getting deployed. Not to don't want to get too far into the weeds on the technicals, but that's the I guess high level concept there, right?
Yeah.
Thank you. And follow-up question is, for domain-specific application, do you need a user to provide some domain-specific image for fine-tuning? Correct?
The short answer is yes. So depending on the task, if it's like a binary classification task to whether decide whether or not a particular part is defective or not, you do need to provide some images with some labels. But again, the amount of data and labels that we require is substantially less than if you were to start from scratch with higher performance.
Brings up a thought as well. We get a lot of, since we've launched the domain-specific large vision models, we've been getting a lot of interest, which is great. I would point out that Landing Lens, and a lot of these folks don't even haven't heard of Landing Lens or tried Landing Lens yet. Landing Lens does work very well for a lot of applications with small data sets, and it is a great place to start to see if you have a use case in mind. And we have a free trial you can see on this page here, so feel free to go check it out. It's a great place to start and see what kind of performance you can get, and then the LVM is kind of the next step if you want to take it even further and get even more performance out of it, right? So highly encourage people to check it out.
Next question, as the LVM is large, oh, sorry, I think it was a little bit shift. What is the maximum image input resolution?
Yeah, great question. So theoretically, there isn't a maximum resolution, but that's going to impact the training time as well as the inference time. So, typically we scale them to a certain resolution to optimize those two things. But I think what's important is whatever class or or defect that you're trying to identify, we need to make sure that the ratio between that class and the overall image is you're not losing information as you rescale. So the ratio is more important than the actual image size. Quinn, I know you have a lot of experience in this area. Anything you want to add there?
Yeah, no, I think the time and expense for the increase in size is the key thing to keep in mind. Like David said, there's a kind of a quadratic relationship between the size of images and how much time it's going to take to actually train a model, and therefore the cost shoots up too. So there are, like you said, creative ways to either rescale the images to the size that is appropriate for the application. There's also, talked about the aerial imagery applications. We have certain customers reaching out to us with like 10 gigabyte images, super big. But the things they're looking for are they don't necessarily need the entire image to be able to find like a car on a road, for example. So there's certain techniques you can apply to like tile those images to the regions that are actually important as well. So there's creative ways to handle it based on the different use cases. Yeah.
Thank you. And does the domain specific only work for specific product, or would the same model work for many similar SKUs with the different features?
David, you want to take that?
Yeah, we're probably thinking the same, but great question. So again, we'll help you define what a domain is. But if let's say you're looking at metal casted parts and you have different SKUs under that umbrella, we would most likely train the LVM with across all the SKUs so that we can learn from those different features. But if the SKUs are completely different, we would probably treat that separately, unless we determine that even though they're under a different umbrella, they're similar enough that we can train an LVM. So hopefully that wasn't too loaded of an answer, but we would essentially train the model with all the SKUs if they fall under the same domain. Quinn, anything you want to add or
no?
clarify?
Yeah, I think that's yeah. It's like it's a kind of a it depends question, right? Depends on the variability between the SKUs, but I think that one of the benefits is that we are able to of these LVMs is that we're able to incorporate kind of more variety, and these models can, assuming you have enough data to support it, these models can learn across that domain of diverse SKUs, right?
Right.
Yeah.
Apart from better, simpler deployment, how does Landing AI domain-specific LVM differ from Vertex AI, which can also be labeled and trained via proprietary images?
Yeah, great question. So, I mean, the models that you see from the hyperscalers, including GCP, they're trained on millions of images scraped from the internet. So I think Quinn alluded to this briefly earlier. They don't necessarily transfer very well. So one of the generic LVMs that we benchmarked ours against from the heat map slides is from one of these open source models or hyperscaler models, which are almost anonymous. So as we highlighted on the heat map, domain-specific LVMs, because they're trained on your specific images, they tend to generalize and pick up different feature maps and learn from those much more efficiently. So when you do apply transfer learning for your downstream tasks, that's the reason why we tend to outperform with substantially less data, labels, and much faster.
Thank you.
That's a great question. Yep.
How videos are labeled for LVM, and the follow-up questions, it was Landing Lens capable for LiDAR data, cloud point, and or other than photogrammetry data?
Yeah, I can try to answer that first, and Quinn, maybe you can add some color here. So for LVMs, we don't need to label any data. We can train on unlabeled data using unsupervised and self-supervised training techniques. But for videos, we would essentially slice them into frames. So if you need to keep or learn from the temporal association of the pixels as you move through frames, we're not training natively on video. We're training on the frames sliced from the videos themselves. And to answer the second question, as long as you can convert a data type into a 2D image, we can train a model, but currently we don't natively support 3D point cloud or any kind of multi-dimensional data sets that are visual.
Thank you. To build our own domain-specific LVM, would you have to put all our proprietary images on Landing AI server, or can we run Landing Lens from our own AWS instance?
When you want to take that one?
Sure. So I think we kind of hit on this a little bit already, right? The Landing Lens will be available in the future as a containerized version, which would allow it to run on your own AWS or whatever cloud provider you're using, or even virtual private cloud, right? So that would allow you to do it that way. And then what was the first part of the question again, Grace? Sorry, I missed it.
So the question is, can run Landing Lens from their own AWS instance if they have to use our server?
Right. Yeah. So I think maybe my answer is sufficient. But again, for the LVMs and the training of the LVM, that actually doesn't happen in Landing Lens today. I think that's something to point out, right? That is a separate task that our machine learning team takes on, and then the trained LVM is something that can be plugged into Landing Lens. Now, we did talk about at the end of the presentation, we'd like to incorporate the training of the LVM into Landing Lens itself in the future. But because it's kind of this offline process, it gives us flexibility to kind of do the training wherever works for the customer. So we can get, again, creative and be flexible in how that happens. David, if you have anything to add there. Yeah. Okay.
Yeah.
Next question, can you create and use synthetic data to train the model?
Yeah, we can. I think it depends on how good the synthetic data is. Yeah, I mean, we do have customers that do use synthetic data for the downstream tasks, but I'm not sure for the purpose of the LVM, it's probably beneficial to run train on production images rather than synthetic images. That would be my guess, but yeah, I think it just depends on the quality of the synthetic data set.
And do all the 100K images need to be manually labeled?
For the LVM, no. Again, we train model on unlabeled images, but we do require some label, a portion of that labeled for benchmark testing, so that we can test to see how much improvement that you're getting from LVM versus either your own LVM or one of the hyperscalers or any of the open source models.
Is there...
Yeah, and that labeled data set can be relatively small too, right? You know, we're training models in Landing Lens with less than 100 images for certain use cases. So, and that can be sufficient for that benchmarking that David was referring to.
Thank you. Is there a free access for individual to try domain-specific LVM for object detection task as a proof of concept before I fed data? from organizations?
There is not a free way to try that right now. So the LVM is a fairly heavy upfront labor activity, I would say, to actually build them, right? So we don't have like a generic LVM that's available to test because it does need to be trained on the specific domain, right? Now, there could be a scenario in the future where we have LVMs for various industries, but that would be contingent on various users, I guess, contributing data to a industry specific model. But that's a bit of a touchy subject as well, right? So in general, the LVMs are trained on the customer's own proprietary data, and the model is owned by the customer, right? But in the future, we could see a route where there are kind of these industry LVMs that are available, assuming the right contribution from people with data.
Thank
I don't know,
you.
David, if you want to add anything to that.
Yeah, and of course, it goes without saying, we're not going to use your data to create our own LVMs,
right,
without explicit consent. Yeah.
Yeah, I think there's a related question. One of the biggest challenges in LLM world is privacy concern.
Yep.
I'm assuming LVM has the same issue as well. Mind talking about how Landing Lens is thinking about this?
Yeah, I think that's exactly what we were just talking about, right? Yeah, the LVMs that we're building, the data is not shared with anyone. The data builds your own LVM that is owned by you, right? So there's not this risk of the data leaking out into this LVM that's then publicly available to someone else, right? So yeah, we hear that concern a lot, especially with, like you said, the large language models. In fact, a lot of the users that we're talking to for Landing Lens are companies are putting in policies where they're blacklisting any websites with AI in them just because they're afraid of people using tools like ChatGPT and having proprietary information go into some big public repository, right? That is not the case with the LVMs, right? These are very siloed engagements with individual customers.
And we have our own GPU clusters locally. So yeah, in terms of privacy, we take that very seriously.
Yeah.
Thank you. Do you provide options to use LVM with different head of a different downstream task? That's segmentation.
Sorry,
So I think,
can you repeat?
Yeah.
Go
I think
ahead.
the question is like, can you apply it for different types of use cases like object detection class, like one single LVM for the various different.
Yeah, you can take
I'll let you. Oh, sure. Then the answer is yes. Yes, you can train a model that the LVM that would then be the foundation for these different downstream tasks like classification, segmentation, object detection. I think that's the short answer, but I don't know, David, if you want to add any color on top of it.
Yeah, no, within the domain, we can tackle all the downstream tasks, especially for projects that are featured on Landing Lens, if you do go that route, including visual prompting, which is what we demoed today.
That too, yeah. Yeah.
Thank you. I have a question with regard to data fragmentation. How are you solving this challenge in a scalable way to ensure LVM access dataset from the same or different domains?
I'm not sure what you mean by data fragmentation.
I don't know.
So are you asking around, I guess, maybe cross-pollination between domains for images? And if that's the case, we have a few proprietary method of first defining what a domain is, and then what data set is relevant for that domain. So if that was a question, that's how I would answer it. But if you can either clarify or confirm.
I think that is what he's, yeah, I think you're right.
Yeah.
I think it's about how you make sure that you're picking the right data to go into the right domain.
Yeah.
Right. And yeah, to David's point, that's a few of the proprietary things that we do as far as the data preparation to build these LVMs.
Yep.
Great. Let's see. I know we are running out of time here, so trying to see how many questions we can go over. Can we use it for image moderation since it provides classification, segmentation, and object detection? Do you think it would be good practice to use LVM in moderation?
I am not sure what we mean by image moderation, to be honest.
Yeah, me neither.
I don't know, Ojen, if you can
Is it
clarify.
like content moderation, maybe?
Well, maybe Ozan, maybe you could share follow-up to clarify, and we can take that one offline.
Yeah, content
we're
moderation
tight
and social.
Sounds good.
Yeah.
Okay, so let's see if we can cover. Are all domain-specific LVM built as a generative models, or do you select the model type based on the domain of imagery?
Sorry, can you repeat that question again, Grace?
Are all domain-specific LVMs built as generative models, or do you select the model type based on the domain of imagery?
I see. We select from a library of models, but we do have, I think, a few that we prefer. But again, the training process is very iterative. So we don't just train a model and send it to our customers. We do a feasibility test first to determine whether or not an LVM is feasible and beneficial to our customers. And then we have a couple of feedback points. First, we would train kind of an MVP model with a set of images. And once we get the green light, we'll scale it to the larger data set. And then we will help you determine the stability of the model and the performance afterwards.
Great. Thank you.
But yeah, sorry, just to add to that, we use state-of-the-art architectures and techniques led by our very own engineering. So, Dr. Ng.
Yeah, we didn't cover all the questions, but we will follow up. If we didn't cover, we will follow up your questions separately after the webinar. And with that, we can conclude our session today. Thank you everyone for taking time to join us today. And special thanks to our speaker, Quinn and David, for the informative session. Visit Landing AI to learn more and stay updated for our upcoming event. Thank you, everyone.
Thank you.
Thanks, everyone. We appreciate all the questions. It's really great to field them.